Yeah. That's the stuff I need to learn.
Okay, yeah. All right, yeah, so the next part we're going to kind of dive into here a little bit more is the actual development of an API using Django. So kind of the next steps here in the training, we'll talk a little bit about the configuration, testing, and then we'll get into kind of the main parts of the Django REST Framework API, the modules, serializers, views and view sets, routes, and routing, which is basically connecting your URL to those views. And then hopefully then touch on some other concepts, like how to filter or paginate your request, like you don't want to serve back 10,000 rows every time or something like that. So definitely control that a little bit. And then things like status codes and exceptions there. Before we do that, though, I just want to kind of give an overview of like the started Django request and response cycle. So if a client or user tries to hit your web page or API through Django, kind of what is the process that happens? That gives you ideas kind of how some of these concepts come into play and like what Django does versus what other things do there. So yeah, at the top you kind of see, you have your client, client, computer or user there, who then, the first step is they make a request. And that request is going to hit your external web server there. This one, it's talking a little bit about Django itself versus the REST framework. So it's thinking you have like actual front-end HTML page where you're going to hit like engine text or Apache or something that's serving your static files. In terms of the static files we're using this other third-party package called white noise, and that ends up taking a place of having that additional engine text server to host those, and we're also still hosted just right within our scene container.
So that's where the static files things came from last year, something called white noise.
Yeah, okay. Yeah, and it gives a, it ends up, making our configuration and our process easier there. We don't have to host Nginx servers, and it is very performant overall. If you want to go back, if you want to learn more, that links to it from the slides there. But from that point, then you hit what's called the WSGI server there. That's where something called GeoDjango comes to place. And that's really what is providing that HTTP front end for our service and taking in the client requests and passing them into the Django middleware. From that point, though, then basically within Django, you have a series of different that was the middleware. You first have the request itself, which kind of takes that information and pulses it out. You don't really interact with that middleware directly. From that point, though, then it kind of looks at that request and the URL or endpoint that you're requesting there. And at that point, it looks at your URL as that time. That file then provides routing into your view itself, so that you'll see something in that file and that says this endpoint and this view. So that connects you over to your views, your settings of view, view.py file there. At this point, then it goes to your model, and your model works with the Django ORM there, where we see the managers level to actually talk with the database. And that, at that point, you're kind of outside, the database does its thing and then sends up back data. That data goes then again to the Django's ORM object resource manager, or it's a manager mapper, or mapper, but it's essentially a manager there. And that comes back through your model, which communicates that back to the view. At this point, then you're kind of talking back to where you're responding back to the user there. Normally, if we're building a Django front-end app, you're going to be creating basically an HTML template, and that's getting fed as a response back. Django REST Framework, though, because we're not really serving front-end HTML websites, we're just serving data back. We're basically using something called a serializer there to go from the complex objects into a simple object like JSON or XML or something like that. And that's what we're going to serve back through the response. The response middleware then basically takes back to your HTTP or human server, and then that gets sent back to your client. Any questions there? Anyone seen pizza yet? Should we maybe take a break here for folks, and then we'll get back into the Django API development? Yeah, okay. Maybe about 10 to 15 minutes. Yeah. How did that go, Ed? Any progress there?
Well, I'm about to try another one. It's throwing a bunch of errors, but I'm going to let it go and see what it does.
You're not getting to access that though anymore?
The SSL is working with PSQL, but not with PG Restore. So that's two great.
We have a little bit more time there until we get to the database.
Yeah.
So yeah, I'm going to go ahead here and continue then. Our next thing, which I'm going to just go back to my last page there. So yeah, we're going to go ahead and then dive into these parts of the RestFramework API development, starting with configuration. So in terms of configuration in Django or Django RestFramework, we're still going to be relying on the basic Django configuration settings there, which are usually generally will happen in a settings.py file. The way we're working here is to just kind of help make that process a little bit easier here to get some of this set up. In the backend Docker container there, we're doing some of the settings already. Let me just open up Django settings just to give you an overview here. I apparently didn't link to that. I thought I did there, but this is the kind of master file which would describe most of the settings you see there. Even Django REST framework, most of the time, most of them are going to be the same thing as default Django settings. So this is a good reference if you're wondering what something is or in there. And in terms of, before you even get there in the back-end file, we're basically doing a few things here. What we're doing is we're setting it up to look at that OS environmental variable you set in the settings for the Django secret key. The secret key is just something that helps to provide a little bit more security there. All that really matters is that it matches in like your environment settings there, so you just kind of need to set something. This is where we're looking at that debug variable, whether it's true or false there, and then we're going to take certain actions depending on whether it's true or false. At this point, we're allowing all hosts to connect to the API, so we're not specifying like a specific IP address or anything there. And that allows, basically publicly accessible APIs. Not sure, do we need to end up changing that to only let the load balancer in? We might have to update that, but the nice thing about this is in the Docker repo, so if we need to update that, we don't have to update the individual project or just update the Docker repo. Installed apps, so there are some of these that are kind of the default middleware there then. Then we have our course headers to basically allow web browsers to access our API. We allow the course across origin resource sharing there. So we built that into the backend itself. Django filters is a commonly used filter system. So when we're talking about filtering by year, greater than, less than, gives you a lot of easy to use filters. So it's fairly standard when you're building a REST framework. And then we're automatically installing in the REST framework and the REST framework Swagger packages. And Swagger gives you an open-ended kind of explorable front end there. So let's see, anything else here? Yeah, we're just adding in the middleware there. We're actually giving a default pagination class in here, but that can be overridden locally. And then what is it? And then also providing additional debugging logging when you have that debug variables that are true there. And that includes things like it actually will log out the SQL requests and some stuff there, so it's pretty useful. And that's where we're allowing the course to actually work And then this is where we end up importing your local settings that you set in the repo yourself. In terms of where am I?
So that part of the settings file, where does that live?
This settings is actually going to be in the Docker itself, so you won't necessarily see this itself, but because of that last statement there, you can end up overriding anything that's already set there as if you need to for your local app. And that's going to be in the settings up high in the local settings directory.
Mm-hmm.
So that's where, like, as we were saying, when you create your first package, it will be here.
Mm-hmm.
But if you create additional packages, you have to add it in there, basically comma. One important thing to understand about Django settings, each of these is an entire object, and you cannot append to the object, you can just override it in total. Mm-hmm. So especially with this installed apps, if you add any new ones, you have to, still keep everything here and override the entire object. So basically, we gave you a basic one to start with. Don't take anything out, just add to it, would be the easiest way to say that. In terms of then, let's see. So yeah, this is what will generate for you. And this will also should automatically connect to the correct static URL for the Swagger front end of hosting there. And it, it spins that, creates that database object there as well. In the cookie cutter, we've commented that out so you can run the basic project and not get error, but you'll want to, actually uncomment and put it in the actual PostGIS database. Yeah, so that's what I was saying, they have to be set in total, cannot be appended. As we kind of mentioned there, we also have configured white noise for hosting the website assets and the unicorn server for the web server development. So the debug variable we set there that does a couple of things. Like I said, it turns on that additional logging. Also, when you're spinning up or running the Docker program, it tells it whether to do a local install of your Python package, where it will update changes, import locally from a file directory within the Docker container, versus in production, where we're actually going to be pulling it from the production PyPy environment there. So in terms of, just before we get into some other code, I just want to take a moment and talk a little bit about testing. We've also included within the repo something called a PyTest Django package, which is built on top of PyTest. And it's one that I found pretty useful and easy to get up and working with running tests as a test run basically there. So it gives you things like statements where you can assert that the response of your request is equal to something or not, like that there. And that's generally how we write tests, is we're looking at, hey, does this response match my request and what I expect there? So we may or may not there use something called coverage too. I think we probably would like to, but coverage will also, when you run your test, automatically give you a report to say how much test coverage have you done for your code. It just gives you an idea of, is my code well tested or if it's not. I'm not going to do anything like mandate 100% or 98% testing or anything, but I would hope that, the more you write, the more tests there are to go with it. The idea of the test there is they basically, provide not only some kind of check that, hey, your code actually does what you expect it to do, but, in the future, we need to make changes or updates. It helps us go back and make sure that we haven't broken anything. So in terms of how we're testing, we've generally done something called dive testing. So we end up connecting to our production database there, which, requires some configuration to make sure that, hey, we're not tearing down the database and destroying production data each time. That should be already set up in the repo for you as well. Nice thing about this is the REST configuration will work in our Travis deployment environment as well as locally there. And that's just kind of some more info on that. So a big thing, nice thing there is to look at the API client, and that actually is something within django-rest-framework. And what that would do is it will allow you to actually test API requests and responses. So you can make a request to an endpoint and check out the response you get. If you're getting the correct status codes, if you say make a bad request versus a good one, is the logic correct, is the data type, all that information there. So I think that's probably a good level of testing for us to rely on, is just making sure kind of the endpoints are returning what you expect. You can get a lot deeper into it, like testing individual units of code, so forth. And if that helps you, definitely go for it there. As you know, I also know we're limited on time, so I want to get an acceptable amount of testing without blocking from actually developing code there. So working with kind of that level of more of integration test, we can see the database, you know, we make the URL request, it connects to the database and gives us the response we're expecting. That would probably be, you know, acceptable testing. So yeah, let's get into some actual code and API development here. So in terms of the first thing that you think about looking at when you're developing an API is probably going to be the model. In terms of, you know, how Django kind of defines a model, is it's going to be a single definitive source of information about the data. It contains the essential fields and behaviors of the data you're storing. And it generally, if you're using a database, there are most situations here we are, each model is going to map to a single database table. So when you're creating a model, here, the first step, you know, basically this will be a models.py file. Your first step will generally be importing models from the django.db at the top, and then you define it. Each model will be a class, so you have your class, the Python class, you have that capitalized, and then it will, you know, there will offer models.model. And then you define each of your fields there. You know, in this example, this gets a, you know, sample one there. We're getting a person with a first name and last name, and each of those is a character or child field with a maximum length of 30. And then you can kind of see here, this would be if, say, you created a database, PostGIS database. This would be the command that would, or a table in your database, which would kind of be equivalent to that model to give you an idea of how those map up here.
Okay, so that's the Postgres, that's what it would execute when you create, when you created the table.
Yeah, let's say you didn't have this already done, you're using Django to create your migrations. We're talking the next page about connecting legacy databases. But yeah, that would be essentially the migration it would create if you already did not have that table.
You talk a little bit about Python, inspect, migrate?
Yeah, that would be, I think, my next slide here. So now in terms of though, if you, so that's, you know, if you're creating a brand new model from scratch. Like generally for Hack Oregon, we're not necessarily going to be doing that there. We're going to be more of working with models or databases that are already in existence, which Django and Django kind of talk of Django speak. They talk about connecting to a legacy database there, something that you're not generating according to Django itself directory. So if you're doing that there, it gives you a nifty way using the Python manage.py to go ahead and inspect an existing database there. So what this command here does is this would within, you know, you have to name your Docker. Let's say you have your Docker container running no query already. If you open a new tab, you could essentially connect into that Docker container through a interactive shell, and then run the Python inspect command within the Docker container there. And then it will have the manage.py in your database connectors.
Yeah, now where is manage.py in our cookie cutter? I couldn't find it.
It's not actually in the cookie cutter itself, it's in the Docker.
Oh, okay, so we'd have to actually go into the Docker image and then it'd be there. Okay.
Yeah, that's where I'm coming from here with the Docker exec.
Docker exec.
So you're actually going into the interactive shell and running this command within the container there. Give me 1 second here, and I'll show that here. Yeah.
Where does the Docker container name come from?
That would be kind of the easiest way to find that if you don't know it already. Let's see. Yes.
Or does the container that we just started running already have a name?
Yeah, that will already have a name there. So you can do basically Docker PS.
Yeah, it'll be like the one called image for API.
Oh, API_1?
Yeah, in this case, it's probably going to be called API. There we go.
Okay, so now I can go.
I'm not sure, it doesn't sound like we've quite got something set up yet. So I might have to kind of show some of this here, just because I'm going to be connecting to a production database. I can't share the credentials out. Let's see.
Username root, right?
What's that?
So I'm trying to
Yeah.
inspect DB or manage.py.
Yeah, definitely there.
I
All right,
don't
so
have a database.
running. Now, in terms of, if you guys want to see, again, what Docker containers you have running, you do Docker PS.a. Has a few, or .a will actually show you all your containers. They don't have to be running. Docker PS should show you what's running there. So yeah, the names. Let's see. Oh, you'll probably be API. This is API development because I have this older version of stuff here. But then I can do the Docker exec -IT API. That's the I.
Okay, so I see. Okay, it's in /code.
Mm-hmm.
Manage.py. Python.
So I should copy and paste. I got the T somewhere, right? You're right. Oh, is it longer? It's actually that whole transportation.
Yeah.
Okay, there we go. So now I'm here in the code directory, and if I do ls, within the Docker container, you can see my manage.py there. So here I'm going to go ahead then, and I can just run my Python manage inspect db. Now the database I'm connecting to also had multiple schemas, and in this project it created multiple databases. So if I remember this correctly, database, passenger, census, and then I just put that to a model, a test. Let's see, example. I'm just doing it to this file because I don't want to actually put it in my project right now itself. I'm just trying to put it somewhere. Now, if I open up let me do it without running that, and you can just kind of see first, and then I'll open the file channel.
Yeah, right.
So yeah, as you can see here, then it's automatically gone ahead and created, gives you those classes without you having to go in and write everyone for every table in your database. It can go in there, look, and actually see that already and print it out in a kind of already formatted Python model. So that's going to save you a lot of time when you're generating your models, connecting to the database the first time there. You don't And it does a pretty good job. You still have to go in and you can't trust it 100%. Things like relationships, primary versus foreign key, sometimes it does pick out the primary, especially if it's ID or something. If you have any, Django doesn't like complex keys much. If you have like, what do they call combined primary keys.
Yeah.
So pretty much you should try to avoid that if at all possible. But yeah, the inspect won't necessarily pick that up either. Some of the fields can be just long or like a char versus maybe what's the other one? But yeah, it's something there to just kind of be aware of. Yeah, there. That, you still have to go back and do some cleanup and stuff. But like, for example here, like look at, how big a thing this is.
Yeah.
If you want all those tables, that's a
a
metro census block. Okay.
Oh, yeah.
You don't want to go there and write every single one of those. So doing the inspect DB is key to just kind of getting that going up and working a little faster there. Now something else that's kind of unique and we built into a Django project is that we did give the option to go ahead and use multiple databases. And you look at settings file basically in the object, you'll have the default Django database, but then you can also create additional ones there. And then if you add basically this code into the top of the models file, and then in the meta fields in DB and then name the database, it will automatically be able to pick up two of the different databases. That can come in handy if your project has multiple databases that you just, separating out for ease of usability perhaps, or maybe, if we're talking about connecting with another team on a project or something, that's one option to be able to do that. Another option might be creating views which connect to their API, but then there's a question of the time. So this gives us some options to connect to multiple databases. Let's see here.
There are some things you have to do on the database end to get this to work for GIS. I know what they are, so if anybody needs that, come get to me.
Yeah.
Ugly too.
Let's see, this does, the inspect DB does get the geometry field there, so the GIS. That will kind of go to a PostGIS or PostGIS data type.
Sorry, real quick. So this is what would be generated as your new models.py file?
Yeah, for running that inspect DB.
Right.
There you would, definitely.
Are you going to talk about the managed at all?
Oh yeah, definitely. And that's the other thing there too that's important with when and this should automatic, when you're doing inspect DB, it should kind of come in there automatically. But the manage equals false tells Django if you're running a migration or something not try to create or update or edit the database directory. So for most of our projects, we're going to be doing read only there, and you'll want to definitely have that set that's managed equals false.
But it makes it so you can create the base schema, and then you can, if you need to tweak it later, you can get some migrations. Or if you add more lookup tables or something like that.
So I actually didn't spend too much here on Django migrations directory, but Django has, as part of its project, something building called Django migrations, and it allows you to control database schema through the Django project itself versus changing in the back end. Django itself will build some default tables in terms of data types and a few things like that there. So you will want it to be able to do that there as well. And we have a code in that, basically the entry point file that automatically runs the migrations. So yeah, let me go ahead and pull up my code here.
What does the NDB mean?
That's
what it already exists, or that's the database table name?
That's the database table. this is not standard there, but basically what I was mentioning here is if you are using a multiple databases in this settings file, this is what allows it to actually connect to the passenger census database instead of the default database. If you don't set it, then it will just revert to default. So if you only have one database in your project, you don't need to worry about that. It will just use default. Yeah. So here then, so let's just say I did that there, then I'll go ahead and take my models file. I could set that command to basically create it in that folder instead of, somewhere there. And then, basically though, I would make any kind of updates I need, and then I have all, I have my models here, mostly ready to go there. Next step then is, now that I have these created, I have that base of the data there that's going to need to be used as the central point. Next step then I would go ahead and do is create serializers. And basically the serializer is a field that handles converting between the primitive values and internal data types. Something called, when you make a Django ORM call to a database, you get something back called a query set, which is a kind of a complex data type, and it's not JSON, basically ready to be returned in the request. So the serializer, we're going ahead and kind of go from that primitive query set type into another data type. It also deals with things like validating input values. If you have a database, or if you have an app where you're actually creating data, you can validate through the serializer that something that's string versus, integer, is the correct date format, things of that nature. And it can also do things like retrieve and set values for parent objects. Not what that means, sorry. But yeah, I mean, the serializers can render stuff very simple, or they can get a bit more complex there. You can do things like logic and in it there. But this would be an example of a very basic one. That's basically, in this case, we're using a model serializer because it's connecting to one of the models we built. And then it basically has this basic class meta. It tells it what model to connect to and which fields in that model to expose. So this is a shortcut here to expose all the fields versus specifying a list of one or two. What we said here is that anytime you're working with a model in your database, you use the model serializer. There's a generic serializer there as well, where you can kind of generally basically create the fields itself. On top of that, though, there's also something called the GeoFeature model serializer. So when you're using GIS data, that's the one you're going to use because it recognizes the GIS.
So would that be serializers.geofeature model serializer, or is there another object that's coming from it?
That's what that's what it would be. I'll get into GIS data later there too. As mentioned, it can specify, and these go to some links to more further documentation on this, but you can specify, specific fields, as I mentioned. You can also customize and add fields that were not originally in the model. If you want to add extra data or make some calculations there, you can do that. And then this is a list of all the different serializer field types. Okay, so going to the django-rest-framework data, so that would be something to definitely know. So one thing there is, generally a single serializer is set up to just return one object. If you're using the serializer for like a list endpoint, like get all your crashes versus just a single lookup, a single crash, then you have to add the many equals true into this metadata there. That just tells it it can return many objects. You know, naming convention wise, you might want to say annual route ridership list serializer or something like that. But, you know, that's probably a convention there. So it won't click it if you don't or something, unless you make multiple things the same. And the serializers can also show relationships there. So if you have a primary versus, you know, a foreign key relationship, you can set a depth on, say, you know, the primary key to go one down and return the secondary objects when you do the call to the original one. That type of thing, or vice versa there as well. And the depth that sets how many levels down the chain you'll go through relationships. Generally, you probably won't want to go more than maybe one level or something, or stuff getting rid of unwieldy there. So in terms of, yeah, this was just kind of a couple of examples of serializers here as well. There, so we have a class passenger census serializer. This one gives you the idea of the GeoFeature model there. And yeah, serializers .GeoFeature model serializer. In this one, because it's the geo one, you end up having to set the geo here, which tells it the basic geometry under it to recognize there. And this one gives you an example here of where you're specifying only 2 fields from the original model. And then actually, as you can see here, I also created a new field that was not on the model called total routes, which was the integer field. I think in this case, in the views, I did a calculation to just kind of calculate how many routes that specific census had in it. You know, TriMet routes, basically train routes plus routes that we counted. So that counted it in total and added that as a field to the response. So because of that, I had to add in this extra serializer here.
Is it good practice or reasonable to do some calculations in the views?
Yeah, I've mostly done it more in the views there. I can't, you know, I like to keep the code kind of in one kind of situational place there. With the views too, then you can also create reusable logic. If you know you're doing the same calculation in multiple views or something like that, you can then put that in a file and import it and kind of reuse that logic too. So yeah, you definitely can there, and that's kind of the motto I followed. That said, though, if you do that, that's where you still, like in this case, my logic was in the view there, but I had to add the actual field I wanted to return into the serializer.
Right, you need to have a space to put it when you do send this stuff out.
Yeah. Any other questions there on serializers?
I forget about the geometry, that's the standard one that we always use, right? 4326 or
Oh yeah, projection wise, that's
but that's if you have something else, you probably want to reproject it to 4326 either in the database or on the web or before, because everything can do the transforms, but it takes time. Like for example, the passenger stops data, the passenger census data had, I think, meters in the Oregon State Plain or something like that. And yeah, you can transform that at runtime, but it takes time.
Yeah, and so this is kind of an example of what the serializer file itself would look like. You know, you have to import serializers itself from RestFramework. After that, you just get to basically, if you're using GIS, you'll have to import their serializers after this one there. And then I end up having to get some weirdness, override those then when I want to use those in individual files. Just because this relies on that, but then it didn't have these, so I had to re-import them.
Oh, okay. Yeah. Now this is in last year's repo.
Yeah, this is it.
Okay.
This code is basically all from last year's repo. I used this year's kind of set up a
yeah.
last year's code, like just
But
kind of have
it's-
something to look at.
But it's not in any of, it's not in the presentation, and it's not in any of the, things we've created this year.
No,
Okay.
it's not. I guess I can remove
No, it'd
my.
be easier it'd be easier for us just to copy it out of last year's
Yeah.
repo and modify it.
Yeah.
Than to put it in a framework that everybody's gonna use.
Yeah, that's kind of what I was thinking there too, so try to keep that as basic as possible. But yeah, this gives you an idea. I guess one other thing to talk about the COIs is, and you figure this out probably very quickly when you try to run your program, but you have to import your models into your COIs file so that they're available here because you're connecting to the different models.
Is that dot models?
Yeah, that's dot
Okay.
models. That's just the import because it's importing from this.
That models.
Yeah. Yeah.
So there's an implied self or something in
Yeah.
there before the dot.
Yeah,
It's,
yeah.
basically the directory structure.
Look in the same directory.
Yeah,
Yeah.
that's essentially what it's saying. It's looking at this package, this passenger census package for the modules.py. Each individual Python file is a module, and then the directory itself is a package. Prior to Python 3, all packages had to have the init.py, this file here, even if it's blank or wouldn't recognize it as a package. But that's actually not true with Python 3 going forward. You don't need to have that file anymore. Okay. So yeah. So that gives you an idea there. So we have our modders and our serializers. Next thing then, once you have those, you want to go ahead. And then you're going to be building your views are going to be what's coming next. The views are where that logic, where that you're exposing that data and telling you what to do to your users there. So, the view, we're not actually viewing HTML or something here. We're not creating templates, but we're creating those API responses in our views here. So RestFramework provides an API view class, which subclass is the Django views. And this kind of gives you a couple of different ways it's different there. So we pass the request, pass the handler method to the RestFramework request instance, not the HTTP request there. And it uses, RestFramework's response instead of the HTTP response. API receptions will be kind of mediated to the appropriate responses, so 404, 500, and so forth there. And then it also allows the ability to authenticate individual requests and permissions and do things like throttling. We haven't necessarily used these as yet, but those are some parts of it here, and this links you to more of the just general view. We're going to get into this deeper here too. So in terms of actually setting up views, Django, it offers you two options, what's the older function-based views, and then it's called class-based views. So function-based views were very individual, like every function would have its own view or view set there, and you would have to basically use decorators and some other fun things there to write in each individual one. So, a PostGIS, a GET request to the same endpoints would each be their own individual view. The newer option here is generally to create class-based views, which help to organize your code into specific classes of functionality. And they've also provided other functionality on top of the class-based views. So generally, you want to be looking at building class-based views instead of function-based views. We have that would give you a little bit more background there. So if you're building off of class-based views there, Django RestFramework still gives you definitely some different options depending on how custom you want to get, you need to get, how much you want to control various pieces of that, as well as if you're, versus if you're just doing a general list or read type of view here. So this is a good website that really gets into some of how it documents out, along with the Django RestFramework documentation itself, all the different types of views you can get here and and, you know, kind of how to use them a little bit, right, to create API view. This gives you all the different methods and functions and parameters of that individual view set. So in terms though, and we'll get we'll get to building some next there. Primarily though, like the mode is kind of built in, we custom, but easy to get up and working. Django also offers view sets, which take commonly used views and groups them together, and basically makes it very easy to just feed in some values and provide a view there here. For instance, if you're just doing very basic list or retrieve, like you're retrieving based on a primary key, and or just, you know, have two endpoints, one retrieves based on a primary key and one lists everything from that endpoint there, you can use the read-only model view set, and that basically handles building your view for you. You just write this few lines of code here, and you have a view set that will both retrieve based on primary key as well as list. So, you know, as you need more customization, do it. But if you don't, they give you some pretty easy things to get up and work in there. Show a more complex view here, some more complex views here. And you're seeing the API guide here. There's basically, if you're looking at Django, this is a django-rest-framework. You have basically 3 pages on views, generic views, and view sets. This is a more than basic, and then this kind of gives you more the generic and view set information there. So it's for your reference. So here's one that I built last year, kind of going back to that passenger census view set. This one is a list view there then. Let's see. So instead of using that view, I think because I wanted to do some filtering on this, I went ahead and used a mixed-in, a view set mixed-in, which was called the generic.list API view. So from that, you can kind of tell it's going to give me the basic list functionality there. So with this view set, I just passed in my query set. So my model dot objects, in this case, I'm saying all, so I'm pulling everything there. And that connects to the Django OOM to basically extract, you know, asterisks kind of thing there. And then I set my filter backend, so I created a passenger sensor list filter itself there, and then I told it what serializer to use there. So those are kind of the basics you might need in creating a view.
So the code we'd actually have to write is the passenger census list filter.
Yeah, in this case, I would have done that. Let me go to my, but if you didn't want to, you know, if you didn't need a filter, that could not be there, and then this would just list all the objects kind of thing.
Well, we're definitely going to need filters,
yeah. So let's go into my views here. Oh, there it is right there. That's convenient. So this is what I'm doing with my filter then.
And which file, that's in views?
No, yeah, this will be in views.
Okay.
You can do string views. I couldn't make, and I did this with some of my queries. I made a separate query file and imported it.
Yeah.
So, you know, if you want to get to, you know, maybe best practice in terms of
best
separating
practice is to have just a few things and a few places.
Yeah. So yeah, how much do you want to make different?
How much searching do I want to do?
Yeah. But also how long a file do you want to? So that's kind of where it is. So in this case here, the passenger census list view. So I you know, it's building off the Django filter backend, which is that install app I said that would be coming in handy there. It's using a lookup choice filter. So it gives me a choice of either exact match or a kind of equals. And then I'm filtering on the field of begin date. So basically that list I could filter to either exact or a similar begin date.
Does that begin date need to match the name of what you assigned that filter to, or that was just so you could keep track of it?
That's a field on the model.
See there is a model on that. Yeah.
See, there should be a begin date here somewhere. summary begin date. I think maybe in my serializer, I might have renamed that.
Oh, okay.
Because if it didn't make sense, maybe. Yeah, I think, so basically that would have connected to that there, and I think I renamed it along the way. But does that make sense there?
Yeah. Do you mind explaining again what what you passed in, the mix-in and the generics?
Oh, yeah, definitely. So that is going to come from here. So that basically a mix-in there. This is passing in some of the basic functionality one would expect when you're hitting this endpoint in the API. So let's try to find it in API, generic views. Let's see. This API view here.
Oh, I see. And so what is a mix-in? What's it? Just more generally, I guess.
Yeah, it's more of a general code kind of thing there where it implements certain methods or processes that it automatically provides to the code you provide in there. Just kind of extending.
I see. Okay.
Mm-hmm.
Cool.
And I mean, this is one of the things there where there are definitely a few different ways to get to the same end goal. It's just kind of sometimes a question of, does it add in too much or does it make you do something in a weird way there? So I found using kind of the mix-ins was kind of the right level of configuration, but also allowing me to add in some of the filters and so forth. Because I think the generic, most of the, the list only view set that I showed first doesn't really give you a lot of the extra filtration options. Find this out.
So I guess where I got confused is you're passing them in there, but you're not actually calling them, I guess, as part of that class, but that functionality is.
Yeah.
So where does that get used, or is that?
So that that's more within the back end here in terms of the. Let me show you there. Let me go to the basic views. So basically, if you didn't do that, you would have to write this out. You would have to actually create your Git view and so forth there. With the mix-in, it already assumes you have a Git class, you have to, edit it, or, in terms of the post, it will have a create or have a delete, depending on the type there. So you won't have to define each of those individual class functions within the class. So now in terms of, here's another example, and this one where I did create, I guess I did bring in the mix-in, I then overwrote it here for the list option here. And this one, let's see, so this one I included a doc string. In general, we'll want you to add these in here as part of the documentation process. There will be auto generation of some documentation. This will pull any of that in and put that into the docs. So don't have to keep rewriting.
Now, does that end up in the basic API document or in the Swagger or in both?
It should actually end up in both.
Okay.
Let's see if we can figure everything correctly there. So in terms of here, now this one here, I'm still pulling all the objects, but then here I'm actually running this other function on top of it. It gets census sorters function. And then I'm telling you what specifically to return. Response here is, a Python response object there. So it's creating, telling it to format the census in that response type.
Serializer class. Def defines a function. or defines a method in a
Method.
class, right?
Yeah, define a method of a class.
That's overriding.
Yeah, because I am using the mix-in, I'm overriding that. There would have been the list class originally, but now I'm overriding it locally. See it. So in terms of, what was that view again here? So the info view set. Yeah, so there it is there. So now, as I said here, I'm running this. I created this other method there, this get census totals method that this is running on top of. And this is a case where I did separate out this logic because it's something I reuse a few times here into a separate queries.py file, so I can reuse it in a couple of endpoints there. Yeah.
So then somewhere you had to have the queries.
Yeah, it's imported at the top of the
You
use.py.
import the queries, or where's your import?
Imported from .queries, I imported.
Oh, from .queries, okay, import.
And this one, I want to kind of show off here because this kind of shows you using a little bit more of the Django RM to make API calls there. So in this case, basically it's looking at, I'll just show you one of these. I forgot if that's the one that matched up or not. That gives you an idea. So we're looking at the census, and then I'm using the Django RM filter command to filter based on this here, service key.
Contains W, yeah.
I contain, so it's a case insensitive contains W, which I think was for weekday.
Weekday, yeah.
So first I'm doing that. So that's, then I'm looking at from that, I think I'm grouping by is what the values was. Every number, summary, begin date, and then doing a distinct. So we're looking at the unique ones in that, and then doing basically a sub-query within that here. And these are all different, the sum, the filter, the I contain, the values, these are all Django RM methods there.
Yeah.
And by using the Django RM methods, I'm basically using these to make the SQL query do this in the database versus doing it within the Python code. So, I could have been like census.all, and then once I got all the objects, filter them down and so forth. But, that's going to take a lot more time because I've just pulled all my entire database, and now I'm going through it.
Now, filter is defined in Django, so we could find that in the Django documentation and see what this.
Yeah, all this stuff, exactly. You'll go to Django or not to Django RestFramework. You're still using the base Django RM methods there.
So you're not writing any SQL, that's essentially your SQL there.
Yeah, and that's the other option. I'll talk about performance here in a few minutes. But you can also do raw, there's ways to write the raw SQL as well and so forth.
Please, no.
It's what,
I want to write raw SQL. I've got a Postgres database.
Yeah,
I can write all the raw SQL I want to.
So and that just gives you an idea of, how, that you can definitely get more customized there and put in your actual code as well. Let's see. The other ones, let's see. In this case here too, if I find myself. There we go. Here too, there's a couple of things, I guess, like we had very small stuff that we don't want to make an entire database, table and take the time there. I've also included a couple of just default Python objects within .py files there. And these can also be imported into your views, and then, for example, there, routes.national. And then this route detail here, I've just done I've created a little query that looks at that JSON and can actually pick out the primary key and so forth. So it kind of acts like a model, but It's just right there in the local Python. So sometimes it comes in handy if you need to add something quickly that's not going to change that, you don't necessarily need in the database.
So why do most of these have a response, but then maybe that one doesn't? Is it already formatted in the right way?
Return response here there.
Well, so that one had to return just route instead of response route?
Well, that is, let's see.
Oh,
Yeah,
that's being used below. That's not actually.
yeah, it's using the get object there. So.
Okay.
Let's see. So any questions there? There's definitely a lot more we can, you can get into views, how to create them. Here, a couple of things there. I have the status code forward not found. So these are the built-in default status codes and so forth there. So this one I added a, try except. See what that, when somebody puts in a year. One more here. So at this point, though, then you would have, models, you have your serializers, and then you have your views. So you have your logic, you have your data, and then you have that connection to how to return that information. So the kind of last major thing here is going to be what's called routing. And that's where you, connect that URL, API / my host API / passenger census to the actual view in your file there. So this generally will be done in the urls.py file. And Django, this is kind of a guide to the routers. Shouldn't have to do, get into too much detail into routers. There, just kind of follow the pattern you see there, and it'll give you an idea of what to do. Let me go ahead and just kind of pull up my example routing file. Let's see, routes.py. Oh no, sorry, that's not the right. You want urls.py. Yeah, it was in there too. There we go. So here, I'm using the default router then. In the Docker container, we're actually creating the Schweiger view, so this won't have to be in your local file there. But it's something that's happened in the background too, so you can actually browse your API. But basically what you're doing is you're registering the specific route or endpoint and then telling it what view to connect to. Base name is actually going to be without the underscore now, because so it's deprecated. I think that's the correct spelling, or you'll get a whole bunch of deprecation messages there. But yeah, so it's pretty basic, what's the endpoint and what's the route and what's the view. So that's what you're going to be doing there.
The reason all routes have to be raw strings?
They're regex, aren't they?
Yeah.
Oh, regex.
Yeah, it's regex there. So because of the way you could actually, if you're really building your own custom views in terms of the gets, the list and stuff, that's the other thing that the mixins come in. They automatically give you the query and query parameter endings there, so where you can put in your filters. Otherwise, you would have to create additional endpoints to route the query parameters. That's where you're asking to it at a certain, begin date or what have you. So yeah, I don't have too much more to say. I was to say on routing, but does anyone have any questions there? Okay.
I actually have a question about it.
Yeah.
So when you were opening that URL file,
are
those absolute paths that you're specifying there, or are those relative base within a package?
Yeah, these are going to be relative to a base here. In terms of this, would be, I think, relative to, say, the passenger census or something like that. And then the base will be, ultimately whatever base we put in the settings there, wherever we're running it. So
like if we're looking at here at service availability, what's the full path? It'd be like localhost 8000 / whatever.
Yeah, it'd be like localhost 8,000 / passenger census / whatever, service availability.
Is it passenger census because of the base name here or because of the package?
That's just, we can set that actually, I think, in the settings. In this case, it's just because of what I think I named it there. Yeah. Oh no, that's the static and stuff. Let me, oh no, it's in the Docker. It actually would be _Oregon _ transportation system / whatever there. And that's based on the team name in the Docker, or sorry, not the Docker, the cookiecutter.
Doesn't it get it from the, back in the URLs part, or register it?
Yeah, let me, okay. Oh yeah, I've got my Docker settings here first, that was importing those. So this is where it's going. So it would be that, then the other endpoint. We could add it, we could do whatever we want there, make it now put in the actual passenger census, I think that's the transportation systems. But that could be, yeah, that would be set. And then anything before that would be localhost or services .@Oregon or anything.
So do you need to specify the base name then if?
That's going to be dependent on the type of views views there. Some of them, I think the generic mixin will require it. If you use the view set itself, it won't. So it depends on which view. So if it gives you an error, then you're going to have to put that in. And where that is kind of when we work as a Swagger, it will organize where the individual endpoints are. Sorry, I keep losing this. Let's see. Here we go. Okay, cool.
I have to get out a bit earlier today. Thanks for the training, Brian.
Yeah, thank you. Yeah, we just kind of showed up the routing. So at this point, let me just kind of show the API running here quickly.
Okay.
I think I already did it. And hopefully it actually starts.
This would be, okay, this is last year's again.
Yeah, it is
Okay.
last year's. So yeah.
It should look exactly like what the website that we have looks like. Okay.
Yeah, what did I call it? Not passenger.
I can go.
Yeah, let me just so yeah, essentially, what you would be seeing here at that point here is this. That's going up on line one. In this case, I already go to passenger census endpoint, so it would just be this stuff here. But if we went to, the info was one of those endpoints I showed there. This is the one that was doing that calculation. So let's go ahead and execute. And you would get a response, something like this. And this is the list there. So yeah, I want to go in and try to get into a couple of those other concepts before we end here tonight. That's to kind of give you some familiarity. So in terms of filtering and APIs, the generic behavior or default behavior is to return the entire query set from a model manager. Definitely any kind of big data set, you don't want to do that.
Yeah.
Or take a while or not be very efficient. So filtering allows you to restrict the data that's returned from the query set. You want to filter based on basically what I call URL query parameters, or that's where you put the question mark something in the URL versus posts with other data stuff there. So we've included that filter backend I showed an example of. in the template, so you shouldn't have to pip install anything else. It should already be in there. To provide extensions, you include the filter fields onto the view then. And then I also showed an example there of creating a custom filter if you want to do more advanced filtering. In terms of pagination, pagination is basically customizing how many results you return. Then usually if you don't return the full result in one response, there's a next page URL that's returned as a header or part of your response that the user can use to get the next set of data and paginate through it there. So the Django RestFramework API allows you to, provide links as part of the content response or as basically the header there. So that's something you can do here, and this is kind of some more guide on how to set that up. We did have that default, I think, 10 return in the Docker container, but you can override that in the filter settings. So yeah, status codes and exceptions, those are important concepts too when you're building API that basically when, if a user doesn't do something right, you want to kind of give them some useful information on, for, not found versus unauthorized versus there's a bad request there. So the Django REST framework provides a full gamut of all the various, full AP, all the different status codes. I guess that's, when you think about when you're using them, use them appropriately. And this kind of gives you an idea of how to set up those exceptions in your code as well. So yeah, I guess in terms of performance there, I was mentioning this a little bit, but Django REST framework performance, how fast things are going, relies on similar concepts to Django itself. So Django kind of goes into pretty depth here in terms of performance and then using certain characteristics there to control how you're pulling the data. As Moss mentioned in our PostGIS training, first make sure your code actually works and it's doing the right thing before you worry about optimizing anything. We want to make sure it's doing that first. So yeah, this is some good guides here on Django performance in terms of indexing, thinking about what you're optimizing for. Some of these things we can do. Some of these things like caching and stuff would require more services. So if you really think that's needed, open up a conversation, we can see what we can do there. This one is very good too there because it talks about a couple of things like let's call it select related and prefetch related. So if you're doing something which requires a relationship, so you're pulling a whole table and then you're pulling, the foreign keys from that or something like that, the default behavior would be pull the one thing and then pull the other thing. Whereas we're using prefetch related, you can start those queries basically at the same time. And that could take something that's taking 20 seconds, like people query data like 2 or 3 seconds there. You want to use these in the right situations because you don't want to pull data when you don't need it. So just kind of understanding what those are when to use them is going to be a good thing there. Also with this, so like JMeter, this is a tool for basically load testing and other kind of testing. It's a Java tool. Like the documented rotation looks more daunting than I think it actually is to get up and working. But if you start getting to that point where you're worrying about performance testing, this is a good tool to kind of get up and working because you can do things like spin up 100 requests to your API and see how long each one is. So yeah, it's something to be kind of aware of if you get to that point.
Where does this install? Is it on the server?
No, you would install this locally on your computer. It's a Java app.
When it's running, is it on the server side of your, or is it on
It's basically it's a JavaScript that's making a bunch of requests and just kind of looking at what kind of response. Yeah.
So it like hit localhost 8,000 a bunch of times.
Yeah, or external server or what have you. So, but yeah, you tell it what to do, kind of tell it the pattern to do it, and then it does it and tells you how many errors it got, how fast it went, and stuff. Let's see. have 3% left here. So we're getting towards the end too, anyway, so. Yeah, I guess a couple of notes here on GIS, GeoDjango. So GeoDjango is a geographic web framework based on Django. It makes it easy and possible to build, web applications like we do with spatially enabled data. So things like, when you're walking across the Earth's not flat, so when you're walking over a curved surface, that changes the distance. Can do all those kinds of calculations. Especially built on top of that is a django-rest-framework-gis package that gives you also filtering for like bounding box and some other cool things there. So
I think it will do everything that's in the ST spec.
Yeah, just about there. So it's pretty powerful, and that's something we generally use and will be built into the framework there. So something to look at more detail as you build your APIs. If you have further questions on that, definitely would be available. So as you mentioned, versioning. We're going to be versioning for GitHub and PyPy there. So the way that's kind of controlled will be through Travis. So you don't have to, other than setting your version, which there will be a program called bump version that you just do bump version minor or bump version major, and it will update the version number there. You don't have to do much with that. Setup.py is what controls the Python packaging, and that's within the cookiecutter template there as well. So documentation, we're going to be using README, Markdown for most of our documentation. You want to basically create a general README. Swagger will create that kind of browsable API we said, and then go ahead and add all your methods in the views and so forth. Create doc strings with that basic information about what it does. And at a later date, we'll add in some documentation generation. And I'll kind of probably have to go around and make some updates there.
Is there a good format for those doc strings, or is there a template?
Yeah, let me get back to you on that, but definitely no. I'll try to get these questions in the next couple of days or weekend. So, this will get some more info of some of the links that we talked about here. Okay, thank you all.
Yeah.
I'm going to make sure I stop the recording.
Before you go, format that for Mac on database.
I can't.